Hey guys, it's Olof here and welcome to the first MakeraCAM video. Now the purpose of this video is just to show you guys the current state of the CAM software, some features that's outstanding, some features that we have available, and just to show you guys the interface and how you can operate and actually create a double-sided PCB. So we'll use the features existing currently to actually make it on the Carvera machine. So yeah, at the top here we have our file, edit, path, view, settings, help. Now these are basically just shortcuts to all the features you have at the top here. So basically file, open save, save as, open recent, importing files. You got 4 sections of import image, vector, 3D model, PCB. Now at the moment we're just gonna focus on PCB. You can also import vectors, yeah, just specific line vectors. If it's a polyline, it might still give some issues. It needs to be a specific export DXF or SVG for you to import it in here. So you can actually use the same tools that we're using for the PCBs. You can use on vectors too. You can import a 3D model at the moment, but you cannot create toolpaths. So this is the toolpath area. So at the top here, you can undo, redo, Control Z, Control Y, cut, copy, paste, basically all these features that you see here. And then you have this little shortcut over here, which gives you the option to transform, create. You can create a circle or a rectangle. So just basic shapes for now. You can adjust image, trace image, and also align things for center to center feature. I'll show you that soon. And then you have your paths, which is this guy over here. Vector path, vector contour, pocket drilling. We don't have vector V-carve at the moment. 3D model path, we don't have that. Rotation path, we don't have that. And then laser path, which is this one over here. So we got laser image and also laser vector, which is the one that we'll use for the PCBs. And then you have your export button over here. If you hold on these two, you can see what they mean. So you can use that too. The zoom feature, zoom in, zoom out, and then you have your left mouse feature. So by selecting, you can now select things on the top view. You can also use this to pan the view, and you can also use this to rotate. But and also to zoom, use the scroll mouse. So I'm usually just on select, and then what you can use is shift and middle mouse, and then to rotate the area. And then if you want to move it around, you use control middle mouse to pan. And so basically I keep that selected, but it's up to you the way that you prefer to use this. You can also click on this to actually create or move around your view. So this is a 3D space. If you're just using the top view, then it is a 2D space, but you can rotate it to see like depths of files. And also, yeah, and the gray area that you see here, that's actually your material that's set up over here. And then your origin on top of the material in the corner here. And then lastly here we have the camera, which is just the view, which is linked to this box over here. So this is basically just shortcuts, this thing that you'll use. But the interface with the left mouse, you can select here which one works best for you. Then we have our stock setup. Now you can open and close it there. And then over here you can edit whatever material you have. And then you can also do that from the top here in the material library. So we'll open this up so you can see over here, there's no specs to the materials over here. So the only thing you can do here is add a material, and then you just import an image to that, and then that will show up here. And then you have your tool library, which is quite a big feature that we have currently. All the bits that you see here currently is the ones that we sell. So the example tools are these ones over here. So that's the basic setup of the machine. And then we have flat end bits for metal, for non-metal corn bits. So everything you can see, you can run through here. If you want to create a new subsection, then you can just add it here. If you want to copy or duplicate a specific section, you can do that over here. You can also delete, and you can import and export other people's files. Or if you want to just save it to another device, you can import or export your tool setup over here. At the top here, if you select the example tool, or like you can select any of the folders. Over here, you can add a tool. So I can add a tool here. Tool name, I'll just do an example. This will be a 2mm end mill flute. Tool number 1, flat end. You've got some different options here. Your diameter, use 2mm. And then over here, you can set your parameters for that specific, for what this mill does in those specific materials. And then you just enable this and you can modify that. And you can add a note to here as well. So that's how you would create a new bit. So there's the new bit created. And then what we've done is we have already set up the specific bits. Let me just delete this one. So we already set up whatever bit you're using with the specific materials. So if you're cutting plastics and you're using the 1/8 of an inch flat end, and you just select the type of material that you're milling with that, and then it will automatically update the toolpath and the feeds and speeds to be exactly what it needs to be. So if you're doing like metal things, or using a 0.2 V bit, this is engraving for metal, then you can select whatever you are actually milling, and then it will set the feed rate, step down, step over, and everything according to that bit with a specific material. So that's quite a neat feature. At the top here, you can edit that tool if you want to modify. You can duplicate it and then modify it from that, or you can copy the tool, you can paste the tool, or you can either delete the tool from the top toolbar here. So quite a neat feature, this tool magazine. So if you have the machine already and you're buying bits from us, then you can just use these as it is. Like here's some drills from 0.2 to 1/8 of an inch, and then for all the specific materials. Okay. Over here you can also change the language to English, Chinese. Over here is just links to our wiki, video tutorials on YouTube, our Discord channels, our support email, and also just about is what the version that you're on at the moment. So yeah, let's get started. We're going to start with the PCB, and what I'll import here is the top section first. So I'll start with the top. That's the top layer. Just go to top here, and then I will also import the top silk screen. Okay. Now, basically a nice feature that we have over here is if I want to do a double-sided part, I can put an orientation or a coordinate system to the opposite side of this board. So what I'll do is over here, I will edit this coordinate. I'll call this one top. And then I'll add another one, and I'll call this bottom. But now you can still see the top one to the bottom. So if I hide this, then this is the bottom side. But I will edit this because I want the bottom to be on the opposite side. So because I'm flipping the board if I'm doing a double-sided PCB. So I would flip the board like this, and then I go to this point, and then that will be the top origin if you flip the board. So that will be the bottom. If you look at this square, you can see now it's on bottom. And then I hit OK. And now this is the bottom side, but it's the top of the material of the bottom side. So after you did your rotation of the stock, then you'll have the coordinate system of the bottom. So let's go back to top, enable these guys, and then the bottom is on that side. So over here, I will import the bottoms. So it's the bottom layer. I will also import the bottom silk screen. And I will also import the drills. So we'll do the drills at the end on the opposite side. So now let's go back to top. Now, obviously you can see it's overlapping. It's going across from the stock. My stock at the moment is 150 by 100 by 150 deep. You can set your different sizes here to be a little different if you need to. But you can also like do multiples, so copy. And if you select everything over here, you can hit M and then move everything around. That's just a shortcut for moving it. Basically, if you select everything, you go here, you can transform, so you can move this part relative to what point you select. But I want to move this part actually just a little bit inwards, just so it actually clears the stock. And that's also that's a silk screen part that's overlapping there. So I don't want that just to be clear. So of the insert to the inside of the stock. So I'll just use that corner as my origin position, and I'll add 3 to here, and I'll add 3 millimeters to there. So now I've moved my stock just or the tool vectors just inside the stock material, and I'm happy with this side. Now you can see over here you can hide each specific layer. So that's the solder mask removal, that's the traces, and then that's the silk screen that we're going to apply. So it's a new method that we're going to show you, just to apply like a white text to a specific PCB. So we'll show you that feature and show you how it looks. I think it's great, and I think it looks great. There's some finer details and modifications you can do. Okay, but let's just get everything set up first. So let me close here. I'm gonna still keep that layer activated. Now I'm gonna go to bottom. Now, because I'm doing this on the opposite side, I need to reverse, or I need to mirror this part first. So we'll do that from this function over here, in position. So, and then I'll mirror this. Everything has been mirrored now. And now what I'll do is I'll select everything. Then I go center to center. Now what you need to do here is select the origin reference graphic. So this is the part that I'll be moving. So I usually just use circles. It's the best to find the center of a different target. And then I go to this one. You can select either one. And then that part lines up 100% with the opposite side. So if I would look at this in 3D, you can see that it's been mirrored and it's on the opposite side of the PCB. So that's exactly what we want to achieve here. Okay. So let's go back to the top. Let's just hide everything here at the bottom. And let's start with so everything is set up now. One more thing I'll add here is I'll create some alignment pins. So I'll be using a 2mm drill bit for the alignment pins. So I'll just create one over here, and then I'll use this transform function. If you move things like this, you want to move the center. So I know this is 100 mil in Y over here, so I'll just make this 50, and I want this to be maybe like 5mm from the side. And now I know that's been moved, and then I will select it again, and then I will select it again, and then I will mirror this on the stock center in the horizontal plane. I will create a copy too, yeah. So now I've got my orientational flip holes. So we'll mold that in the PCB. So when we flip to the opposite side, we know it'll be exactly in its position. Now on this top layer PCB, there's still some modifications I need to do. So I exported with the top layer from my PCB design software. I exported this external border, which is going to complicate things now. So what I'll do is I'll just delete it. It's just an outside border because this needs to be a pocket. So this needs to be milled out, and those traces needs to be milled out. If it reads this, it will see this as material. It will see that as a cutout. So I will just delete this external border. Just something that you might pick up in your files. Just something you have to modify in some cases. You can also export from your PCB design software, you can export it without that border. So just keep an eye on that. Now what we'll do here, we'll select. We can also go in top layer if it's not square or things like that. You can select the graphics from here too, and then we will create a pocket basically. So we're not using the lines. We're just going to be using the pocket feature, and for this we will be using, let's say, there's a top traces. We will start at 0, and then we'll cut into the depth would be 0.05 millimeters. The save positions has already been set up. C3, and now here we will use a corn bit for that actually. So nice feature that we have over here is you can, for example, because we're clearing out this area and we're also clearing out the smaller details like that. So what you can do here is you can choose 2 tools. The one will be the 0.6 corn bit, so that's fine. We've selected that for PCB. So we will, and then we will choose also a detailed V-bit, engraving 0.1 for PCB, choose that. So over here, you have to have your bigger bit at the top. So when you calculate your toolpath, it'll look at the first tool, it will look at the top tool first, and then it'll do the calculations of that. Then it will look at the second tool and do the finer details with that. So even if there's even finer details as 0.1, it's not in this case, but like then you'll add like a smaller bit down here to do another tool change to another bit. The only thing that you have to modify is just to make sure your setup is correct. So in my case, 0.6 is the corn bit in my tool, and then this will be tool number 2, the engraving V-bit. I'll put a section over here just to show you what my machine setup is at the moment, and then we'll just reference it back to that. So that's set up, and our feeds and our step over and our feeds, plans, everything is already set up for PCB. So then what we'll do here, we are doing just an offset path strategy for parallel. You'll use that if you're doing like big surface milling of materials, but in this case we won't need that. At the moment we're only doing convectional. We don't have the climb option yet, but for this case it's not a problem. So we will calculate that. The top traces, just check everything, and we'll calculate that. And then you'll see it should just give you a little percentage of its loading its toolpath, and here you can see your toolpath has been created. So first of all, it'll use the 0.6 corn bit just to clear out the big areas, which is like these areas, and there's one more area on the PCB here where it uses the 0.6 corn bit, and all those areas over here. Yeah, I always just zoom in just to double check if everything is exactly how it's supposed to be. Maybe you can pick up some errors here. You'll also be able to see if your traces are too small. If there's like no lines showing here, then your machine's not going to cut a trace there. So yeah, but this looks good to me. We've calculated that, and then you can see here tool number 1, tool number 2, top traces. So we're happy with that. I'm going to hide this. Let's go to our solder mask removal for the top side. So I will select everything here just to make sure I have everything selected. You can also select that here, like I mentioned. And then we will go and we'll do the same thing. This is also a vector pocket. So this will be top solder mask removal. In depth, we will make this 0.2 depth, start at 0. The save position has already been set up. We're going to have to change these. So I delete that tool, delete that tool. Then I'll go to my solder mask removal for PCB, and I'll choose that. And you'll see everything's already set up here. This is tool number 6 on my tool holder on my machine. And then I'll calculate that. easy as that. And you can see all the holes has been calculated. I don't see anyone that's been missed. So that's good. Top solder mask removal. Or actually, what I'm going to do is I'm going to rename this. I'm going to call this 1. 2. And then as I go, I'll just to keep kind of track of which part of the procedure this goes on. Okay, so we're happy with that. I'll hide these, then I'll open the silk screen. So now this is the new feature that we've kind of figured out a good way to apply graphics to your PCBs. Now this is a white solder mask that we'll put on top of the green solder mask, or whatever color you're using for your base as for your PCBs. And now what we'll do is we'll create a laser toolpath onto the white solder mask just to harden it in specific areas, and then you wipe off the rest of the solder mask, and then you're actually left over with like a white text on this. So this can either be, you can either do this right after the traces or before the top solder mask removal, or you can do it after. It doesn't really matter. So this will be, let me just close this. This will be a laser vector. So this will be the top solder mask application that's already been, text is already set up. Speed to, this is the feeds and speeds that we've tested, and it worked quite well. This, you can obviously modify this. You can also change here if you're filling or you're doing an offset of the fill. But what we're doing is we're just using the line, and then we're actually putting a little inside offset of that line. So let me calculate this and I'll show you. So it's actually seeing, it's using this as the reference, and then it's doing a 0.14 offset in millimeters to the inside of that text. So it's actually a double line that's running on the inside of this text. It depends on also how big your font is, but you can modify this. You're gonna have to play around with this number if your font is a different size. But for this results that we're getting, for this size font, this was quite good results. So we're happy with that. And then, yeah, that will be tool. Let me just call this 3. And that's everything you have to do on the top side. So let's hide that. Let's hide that. Wait, we still have to do the drills. So let me select the drills. They are under a new layer. So if you create anything new, then it will just go under a new layer. Or if you've selected a different layer, you can add it to that. So this will be just drills. So this will be vector drilling. Drill processing 2 millimeter. This will be 4. And we are going into like, I'm setting this up with like a 10 mil stock underneath the PCB, so we can actually like put the alignment pins deep into that. So I'm gonna go 10 mil from the top of the PCB into the PCB, and then into the stock at the bottom. And then this has already been set up. The tool we'll use here is a drill, 2 millimeter drill into PCB. So I'll choose that. And this is tool number 5. Here you have some drilling strategies. The one is none. That just goes directly to the depth. Then you have your fixed Z height, which goes down 1 millimeter, goes back to safe Z, and then it goes down 1 more millimeter back to safe Z. Or you go relative retract. So it drills down 1 millimeter, lifts up 1 millimeter, drills 1 millimeter deeper, 1 millimeter. So this is the option that we used for this, and it worked out quite well. So we'll just calculate this. Oh, it's not selected. Select graphics, calculate that. And if I hit shift middle mouse, you can see that it's actually drilling into the PCB and into the stock at the bottom. So happy with that. And we'll close that. All sorted. Now we're going to go to the bottom. So let me just keep this on. Then I'm going to go to the bottom, but nothing is showing at the bottom. So I've flipped the board now into the alignment pins. And now I will do the opposite layer. And now you can see everything's already been aligned. So it's going to be as simple as just doing the same thing we did now on the bottom side. So we'll start with this, with the traces. Now on the top side, we deleted the outside border, but we still need this as the cutout. So the final pass will be the cutout of this. So what I'll do is I'll just move this to new layer, and then we'll do at the end, we'll do the cutout using this layer. We'll do the cutout of the board. Okay, so select everything. We go to vector pocket. This will be bottom, bottom traces, starting at 0, 0, 5. Save setup, delete this tool, and we will use the 0.6 corn bit in PCB. Select that one, and then we'll add another tool, which will be the single flute 0.1 for PCB. Choose that tool. Everything here has been set up. This will be tool number 1. This will be tool number 2, and then we will have the offset. Calculate that. And we have our traces at the bottom. So here you can see there's a little bit more areas that the 0.6 corn bit is billing first. So it's a few areas over here. Obviously the 6 tabs, some area over there, some areas over here. And just looking at the details, everything looks quite good. It's like a double toolpath on each trace. So I think the details will be quite clean and fine. Okay, we've calculated that. So that's tool 1, that's tool 2. Happy with that. We close this, we close this, we go to solder mask removal. So everything we select here, we close. This is also a vector pocket. This will be bottom. Solder mask removal. And we are cutting at a depth of 0.2. And we are not using these tools. So we are using the solder mask removal tool for PCB. Choose that. Then we have everything set up here. We know our solder mask removal is tool number 6. And let's calculate that. You can see this whole area has been catered for. All the vectors has been taken care of. So that'll be, just close this, just go back. This was number 4 process. This is number 5. This will be number 6. And next we will do the silkscreen application. So we'll select these guys. We'll go to toolpath, vector laser. This will be the bottom solder mask application with the same details as we did on the opposite side, and we'll calculate that. You won't see the tool. No, you actually do. Over here you can see the tool path. It's like a double line on the inside of all the text. So this is just an example now to show you. Now this details that you have on the board is so small, so it doesn't, the offset for 0.14 doesn't even pick up these this area. So I don't need this for the specific PCB, but this is just a good way just to show you that if the traces are too small or the export is too small to each other, you can actually go on the line too. But we found that we can actually get a little bit more detail if we put it on the inside of this text. So if you're actually milling on that line and on that line, the font is very thick. So yeah, you're gonna have to play around with that. This is not specific to this PCB, and your PCB might be different. Your text might be a little bigger. But yeah, that's what we're trying to achieve here. Next, we will go with our drilling operation. Now, a good feature that we have introduced in our CAM is when you design from your PCB CAM software the drills, or you export the drills, you don't have to export them as separate drills. So you can select all your drills from your PCB design software, export them as a single file. Like you saw when I imported this file, it was just one file. But when I imported it here, there was actually 1, 2, 3, 4, 5 different toolpaths or drills to that specific file. So it actually splits them into their specific hole or specific drill sizes. This will be a 0.3, 0.5, 0.6, and then 0.7 and a 1 mil drill bit. So what we'll do on this specific job is we'll use a 0.3 mil drill bit for that hole, 0.5 drill bit for that hole. We'll use a 0.6 corn bit for this hole, and then we'll use the corn bit as a pocket for the 0.7 and also for the 1 millimeters. So I will select the first one, select these graphics, and I will go to my vector drilling. This will be, let me just modify this. This was number 7, bottom solder mask removal. Okay, and now we're going to 8. So this will be 8 drill processing for the 0.3 millimeter drill bit. And then we will go at a depth. Our material is 1.5, so we'll go at a depth of 1.6 or 7. That should be fine. And then we're going to choose our tool, which will be our drill. It'll be our 0.3 drill bit. And this will be tool number 3. And calculate. Now I will just hit shift middle mouse, and you can see everything has got lines going from top to bottom. So it's actually drilling through the material. If you want to view it like that, you can. So happy with that. Tool number 3. Let's close that. Let's hide this, hide that one. Then we're going to go to our 0.5 drills, and we select them. And we will go to vector drilling. Now this would be our 0.5. This will be our 9th operation. Starting at 0, end depth 0.7. Choose tool, drill 0.5. Drill bit into PCB, choose the file. And this is tool number 4. Relative. Graphics not selected, that's fine. Select the graphics, calculate, just to see if they actually showed up there. I just like to rotate it just to check they're all there. So happy days, close, close. Then we go to the 0.6. It's 0.599, but it uses the center point. So if I select this graphics, I'll do a drilling file for this. 0.6. And this is using the 0.6 tool bit. So that's tool number 1. Oh, let's just select it first. PCB, choose for tool number 1. 0.6 corn bit. So this is just using the corn bit to drill. Calculate. It's just 4 holes. Close that, and then we will select both these files. This one, shift, and this one. Select these graphics, and then we will use this. Because it's bigger than the 6 millimeter, we can actually do a vector pocket. So it's actually like going to rotate down to mold these holes. And this will be called Just a second, let me just sort out this. Didn't rename this correctly. That was process number 10. And now we have these two selected. And this will be the 11th operation, drill processing 0.6 plus. 0.6 plus. Okay. And we will choose our tool, which would be our corn bit 0.6. Choose, delete this one. We're just using that one. And that is tool number 1. This is the only thing that you kind of have to like look at is your tool numbering. So let's calculate that, see if all the holes show up. Okay, so it was still using the wrong depth. This is still 0.2, so I just missed that. I'm actually milling this at 0.7. Let's do that again, calculate, and I'll see it spirals down to create all the holes with the bigger holes in 6mm, but with the 6mm bit. So we are happy with that. We got our drills, now close. Now the final thing is we've drilled all our holes. We've drilled all our holes. The final thing that we'll do is just use the border that we copied to new layer, and we will create a vector contour for that. So not a pocket. Everything else we use the pocket for, but for this will actually be a cutout. And then this is operation number 12 for the cutout, and we'll actually use the 0.6 corn bit for that, which is tool number 1. We're going at a depth of 0.7, so we just mold through the material. You can also add tabs here, but for this PCB I don't necessarily need the tabs because I've got it mounted with double-sided tape to the baseboard, so it can't really go anywhere. And then I also have my stock that's underneath the PCB also mounted with double-sided tape. So I don't necessarily need tabs, but you can add tabs over here. We have selected, just to go through here before I get there, this is an outside cut that we're using, so we're using that line and we're cutting on the outside of it with the 0.6 bit. And you can see here the step down has already been set up as 0.3 for the 0.6 corn bit, so everything's good over here. Here you can add your custom tabs by just, if you go to bottom, you can still add your tabs by selecting here. There's still a bug that sometimes the tab goes to this corner, so just clear the tabs. You're just gonna have to make sure that it doesn't go to this corner, so or that corner. Yeah, so there's still a little bug there. We're still working on that. Don't worry, it's not a train smash. You can still add your tabs. You just have to be selecting them just at the exact position, then you should be okay. Okay, I want to clear that tab. I don't need them. So let's calculate that outside cut, and then that will be the 12th process, and then we have our cutout. And there we have the top and the bottom toolpaths all created. What we'll do now is we'll right click on each of the toolpaths to export them. So now I've just exported all the files together, or how I will import it to my machine. So the top trace is separate, top solder mask removal separate, top solder mask application with the laser is a separate file. Alignment draws is also a separate file, but you can also include that with the top solder mask removal or the top solder mask. Yeah, so you can actually combine them together just so it picks up the tool and does the alignment draws. Then the bottom trace is also separate. The bottom solder mask removal is also separate. The bottom solder mask application is also separate because we are removing and then the drilling and the cutout we've combined to one file. So all together we have 8 toolpaths we can put onto our machine and get going.